Chapter 3.3, prove lines are parallel. So I made these notes as a summation of this section in the chapter. They're very similar to the previous notes that we had. Okay, it's ways that you can prove that the two lines are parallel. So if two lines are cut by a transversal, if the corresponding angles are congruent, or the alternate interior angles are congruent, or the alternate exterior angles are congruent, it proves that the two lines are parallel. Okay, and once again, if two lines are cut by a transversal, if the consecutive interior or consecutive exterior angles are supplementary, then it proves that the lines are parallel. So that will all be in this section. So the first one is for the corresponding angles. Okay, if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So in this diagram here, we have angle 2 marked congruent to angle 6. Okay, angle 2 is on the top right of these four, and angle 6 is on the top right of these four. So they are corresponding angles and they are congruent. Since corresponding angles are congruent, it proves that line J is parallel to line K. Example 1, find the value of x that makes M parallel to N. So in order for M to be parallel to N, corresponding angles must be congruent. All right, corresponding angles must be congruent. So we can see this one is on the top right, and this one here is on the top right. They have to be the same measurement, so I'm going to set them equal to each other. 65 equals 3x plus 5. All right, and then just solve for x. Minus 5 on both. 65 minus 5 is 60. And the 5 minus 5 cancels. Bring down to 3x. And of course, dividing both sides by 3. X equals 20. So that's all they asked for. And of course, if you plug 20 in here, 3 times 20 is 60 plus 5 equals 65. So it checks out. All right, try this one here. See if you can prove that line M is parallel to line N. And I'll give you a hint. Find the angle that corresponds to 105 or the angle that corresponds to 75 and see if they're congruent. All right, this angle here, 105, is on the bottom right. So if we look at the corresponding angle up here, that'd be this angle right here on the bottom right. We know that a straight line, if I can highlight the line here, we know that a straight line is 180 degrees. Okay, so if I drew an angle from here to here, that would be 180. All right, so if this one is 75, the one right there is just going to be 180 minus 75. And of course, that's 105. All right, so if this angle here is 105, and I'll erase this mess. If this angle here is 105 and this angle here is 105, corresponding angles are congruent. That proves that M is parallel to N. So both corresponding angles equal 105. All right, so for alternate interior angles, if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So this is the interior between J and K. All right, and this is the transversal. I'll label it T. Angle 4 is on the right. Angle 5 is on the left. So they are alternate interior angles, and they are marked congruent. If alternate interiors are congruent, that proves that line J is parallel to line K. And the same is true for alternate exterior angles. If the two lines are cut by a transversal and alternate exterior angles are congruent, then the lines are parallel. So in between is interior. We can see 1 is outside of the two lines and 8 is outside of the two lines. Those are exterior angles. 1 is on the left, 8 is on the right of the transversal. So they are alternate exterior angles. So when alternate exterior angles are congruent, it proves that J is parallel to K. It proves the line's parallel. All right, if two lines are cut by a transversal, so consecutive interior angles are supplementary, then the lines are parallel. So remember, consecutive, that just means same side. So again, this line, diagonal line, that's your transversal. I'll label that T. Okay, in between the parallel lines is the interior, and these angles are both on the left-hand side of the transversal T. So those are same side or consecutive angles. And they're on the interior, so they're consecutive interior. So if consecutive interiors are supplementary, that proves that J is parallel to K. So line J is parallel to K as long as these two angles add to 180. Now, they don't have one for same side exterior, same side or consecutive exterior, but it's so easy to prove. Okay, right here we have 3, angle 3, and by the vertical angle, since there's an X shape here, this one is going to be the same measurement as 3. Okay, and right here, we have angle 5. I'll use 2 marks this time. And again, there's an X shape right here. These are verticals. So this one right here is going to be the same thing. Okay, and then right here is exterior. Right here is exterior. They're both on the right. So these are same side exteriors. And they would also be supplementary if the same side interiors are supplementary. So it's really the same thing for the consecutive exterior. All right, example 2, how can you tell whether the sides of the pattern are parallel in the photo of the diamondback snake? Let's see. Okay, here's the photo here, but they expanded the photo. All right, I am going to trace over what they already have in the photo. See if that helps. Okay, they have these 2 lines here, and then they have this transversal line right here. And then they have this angle marked congruent to that angle. All right, so this line right here is going to be your transversal T. See if you can explain why the lines are parallel. All right, in between the 2 parallel lines is considered the interior. Both of these angles are in between, so they're definitely on the interior. All right, and I see one angle is on the right-hand side, and the other angle is on the left-hand side. So those are alternate interior. Okay, and they're both marked the same, so they are congruent. So alternate interior angles being congruent, that proves that the lines are parallel. Okay, try number 3 and see if you can explain why or why not the lines are parallel. See if you can explain that, if you can prove it. All right, so this horizontal line is your transversal, that's T. Okay, in between the lines is the interior. So clearly these two lines that are marked are angles that are marked in red. Those are exterior. All right, and I see one angle is on the top of the transversal and the other angle is on the bottom. So they're not on the same side. That makes them alternate. All right, and they're marked with the same angle. They're marked congruent. So alternate exterior angles are congruent, and that proves that A is parallel to B. Okay, try number 4, please. So out of these 4 angles right here, this one is on the bottom right. Out of these 4 angles, this one is on the bottom right. Since they're in the same position, those are considered corresponding. All right, and they're marked the same. So those are congruent. And that proves that A is parallel to B. Okay, line A and line B. All right, try number 5, please. This horizontal line is the transversal. I'll label that T. These angles are both on the interior. So these are interior. Okay, angle 1 is on the top. Angle 2 is on the bottom. So those are alternate. All right, and alternate interior angles need to be congruent. Now, did they mark 1 and 2 congruent? No, they did not. They said they were supplementary. They said they added to 180. Okay, so they might be congruent if they were both 90, but this alone does not prove that A is parallel to B. Okay, they would have to be marked congruent. Okay, just because they add to 180, that does not prove it. If they were same side or consecutive interior, that would prove it. But these are alternate interiors. All right, example 4, in the figure, R is parallel to S, and angle 1 is congruent to 3. Prove P is parallel to Q. Let's see. All right, so it said R is parallel to S. I'm going to mark them parallel. Okay, so I'll draw these little arrowheads on R and S, indicating that R is parallel to S. And it also said that 1 is congruent to 3. So see if you can explain or prove that P is parallel to Q. See if you can explain it in paragraph form. All right, if R is parallel to S, that's given. I can use this line on the bottom as my transversal. Okay, so I'll call that T. Out of these 4, this one is on the top right. Out of these 4, that one is on the top right. So if R is parallel to S, then 1 is congruent to 2. Okay, angle 1 is congruent to angle 2, and that is because they are corresponding. All right, they're in the same position from one line to the other. Now, it was already given in the write-up. We marked it that 1 was congruent to 3. Okay, it was given that 1 was congruent to 3, but we just said 1 was congruent to 2. So 3 is going to be congruent to 2. All right, and as a result, we have if we use, now instead of using Q as a transversal, we'll use R as the transversal that cuts through P and Q. All right, these are both on the interior. 3 is on the left of the transversal, and 2 is on the right of the transversal. So those are alternate interior. And they are congruent. All right, since we said 3 was congruent to 2, those are alternate interior angles, 3 and 2. And those are congruent, so that proves it. So that proves P is parallel to Q. All right, this is a separate theorem, transitive property, parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So right here, if P is parallel to Q, so I'll mark P parallel to Q, and Q is parallel to R, I'll mark Q parallel to R, then P is parallel to R. So this one is parallel to that one. All right, pretty simple. Example 5, the flag of the U.S. has 13 alternating red and white stripes. Each stripe is parallel to the one below it. Explain why the top is parallel to the bottom. Okay, so they numbered all the stripes, S1, S2, all the way up to S13. Okay, and so we could just say if S1 is parallel to S2, and you just keep going, S2 is parallel to S3, because it said that the one above is parallel to the one below, and then you just keep going, and you'll finally say S12 parallel to S13. Okay, well then S1, the first one on top, is parallel to the last one on the bottom, S13. Okay, so you just keep going, you just keep counting down until you get to the S12 parallel to S13. And that would prove that S1, the top one, is parallel to S13, the bottom one.